changes in their approach to adequately prepare students with the required 21st century skills. Technology is transforming the ways that people work and relate to each other, which means that learning in schools needs to change to adequately prepare students. Education should be much more about ways of thinking, which involve creative and critical approaches to problem solving and decision making, whilst also emphasizing learning. Education should also introduce ways of working through communicating and collaborating, as well as refining the necessary tools for working. These tools include information literacy and ICT literacy. And last but not least, students need to develop the skills for living in a multifaceted world as an active and engaged citizen with personal and social responsibility.
So this is going deeper with Python Theano. If you're expecting a machine learning talk where I will talk about k-means and Hadoop, this is not the right talk. This is all about deep learning, which is hot stuff in kind of Google Labs, but it doesn't require huge clusters of machines necessarily. About me, so I did some kind of finance stuff, some startup stuff, some machine learning stuff. I came to Singapore about almost 2 years ago. Last year I was just having fun doing machine learning. I came here as a Pythonist, but I had a kind of little affair with Go, Scala, Node, Haskell along the way. But I've come back to Python because of the kind of the ecosystem and this Theano thing I'm going to talk about. This year I'm doing serious NLP and actually getting paid for fun, so that's good by me. So, quick outline, I'm going to talk a bit about what people are doing with this, why Python, Theano and whatever is a good choice, and there's going to be some demos and code, but it's all a bit a mishmash because some things you need to know up front, other things are kind of interesting as we go along. Hopefully you can follow me. So deep learning, basically these are neural networks in multiple layers fed with tons of data. A bit of history, back in the 80s, everyone thought neural networks were going to solve everything. But by the mid-90s, people had enormous problems solving the XOR problem, which is like the simplest problem. And basically it went through a long winter until about 2005. There are a few people who carried on the faith, but basically it turned into a bit of a wasteland. But in 2005, suddenly they discovered they could train deeper networks. And it really worked, which is a surprise to everyone. And then 2010, people started to put these on GPUs, which means that you can now look at serious quantities of data in realistic times. So, so the people who are involved, basically there's a group of people, Hinton and LeCun and Bengio. These are the stalwarts who continued through the AI winter. They kept at it, but now they've all moved to the big names. Apart from his son is, I think, one of the big names too. But basically, there are some centres who are doing, this work at scale and publishing all about it. So the basic approach here is really the same as neural networks always used to be. So this field has been around for 30 years or more. So basically, you take some very simple mathematical units, you combine them. How much we're going to combine them to compute complex functions, and this is really about supervised learning. There are other clever things you can do. So here we are. This is a diagram of a simple neuron. If you've seen anything like this, this is a very familiar diagram. Basically, at the bottom you have an input, then you have a series of weights, and essentially to calculate the thing in the middle, you do a dot product. You may add a bias term, and then you apply some kind of nonlinearity function. So that gives you one output. So here we have a vector going in, some weights, to a single output. And basically by changing the weights, you can change the function which the output is producing. And what you then do is say, okay, what I want to do is I have several outputs and more inputs, but also by having some hidden layers in the middle to compute kind of intermediate representations, this becomes a more powerful function you can compute. And the trick is, how do you train everything? Because these hidden, if I look at this hidden one layer, it's connected to the inputs, but only indirectly to the outputs. So the basic scheme for supervised learning is, until you're ready, which is a kind of a how long is a piece of string, you pick a training case, which will be some X, and I have a target Y that I want to learn. And what I do is I take my network and I say, well, what is my network telling me for my output? And then I want to twiddle all of the weights until my output is close to the target. And the trick is, how do you twiddle these things? Basically, you try and do some kind of gradient descent. You can calculate just the sum of all the errors.
Hi, my name is Aditi. I am 7 years old. I go to St. Mary's School. At school, when my teacher teaches me maths, I have trouble with my numbers. When I must to read in class, my letters seem to get jumbled up. When I came home from school with my spelling test, my mama got angry looking at my result. We visited a kind lady. Her name was Mrs. Counselor. She told us I have a learning disability. What is learning disability? Learning disability is a neurobiological disorder.
Just a quick remark. So I was being asked for an example of where you can see this modularity of Torch code. So one that I like, I'm going to cover this in class, but if you're eager to get to see how this is done, have a look at the GitHub code of Wojciech Zaremba. You can just Google LSTM Zaremba. And that's the code for his paper, Learning to Execute. And there's two modules in his code. There's an LSTM function, and then there's a network. And this stuff that Alex Graves has been using for a long time. And if you put these very simple modules together, like some researchers at Google have done, you can build by using simple, each module here is itself an interesting type of network that goes inside here, but we can combine them in sort of temporal structures that have memory in them. And we're able to actually, if you provide sentences in one language and sentences in another language, it learns to translate. So you have a model that learns to go from one language to another language. And you should think of translation as a very general way of going from one kind of data in a sequence to a different kind of data in a sequence. So you could go from English to a sequence that basically tells you the structure of that sentence, that tells you what's a noun, what's a verb, and so on. You could have music to language, or you could have gazes in an image, and then a description of what it is that you're seeing as you're gazing at the image. And all of these things have been done. There's so much, you could have speech commands, and you could have a sequence of actions of a robot, if you want to control a robot. If you're playing computer games and you want a sidekick character that, you're sort of shooting monsters or whatever you're doing in the game, and you can ask your sidekick to, run the monsters or whatever it is you want it to do. The approach leads to being able to build such models that are extremely flexible and extremely powerful, and that actually make us question some of our beliefs about what can be learned and what can't be learned by machines. Like for example, what I mentioned, going from a sentence to syntax, that's showing that you could learn syntax. It's in itself quite interesting. For many years, people thought that syntax is something you couldn't learn. Right, but in this lecture, the focus will be on ConvNets. These models are probably the most popular, besides these new things, LSTMs, are the most popular models in the world of deep learning. And because if you want to solve problems, this is the reason actually why companies are so interested in this, because ConvNets allow you to do object recognition. Given any image on the web, you can figure out exactly who is in that image, what are they wearing, in what pose are they, etc., etc. So don't try to protect your information by encoding it as an image, because any text in an image can be read.
I'm a teacher, and I have a question. How do I prepare students to succeed in the 21st century?
Today, students will face challenges we haven't imagined, take jobs yet to be invented, and toil in a workplace constantly reshaped by the exponential progress of technology. Only one thing is certain. Classrooms designed for the industrial age won't prepare students for this dynamic era. A new century calls for a new paradigm.
So what's my role?
We need to reset our sails and navigate these uncharted waters with our students. The sage on the stage must become the guide on the side, no longer the knowledge keeper, but the chief knowledge seeker, learning along with and even from students. Competency must shift from knowing the right answer to asking the right question.
What kind of car will you be driving 20 years from now? Or will it do the driving?
Will future conflicts be waged over oil or water?
What do we do if sea levels rise as predicted?
And reimagine classrooms where students become information producers rather than information consumers. Questions spark curiosity, encourage critical thinking, and foster creative solutions, skills our students need to adapt to any situation and compete on a global level.
How do I prepare for this role?
First, by recognizing that our students, digital natives, view technology as an extension of their nervous systems. It has literally shaped the way they think. It's the key to connecting with them and a bridge to learning. The skillful use of technology puts the world at their fingertips, makes deep investigation possible, and provides a flexible, engaging format for project-based learning, so essential to building critical thinking skills and preparing students for the workplace.
And where do I learn these skills?
At a college of education that's striving to mirror the classroom and the workplace of the future, with collaborative learning, multi-platform competency training, and a philosophy that encourages teachers to imagine new and creative ways to reach students.
What if I created a project that allowed my class to work with students around the world to document climate change?
Could a teacher in Argentina tutor my Spanish students in real time? Why not?
How can I design a project that gets my young students excited about the creative power of math?
Do you think in 2020 that you'll wear your next computer on your finger or under your scalp? And what kinds of opportunities does that present?
The 21st century provides enormous challenges for educators, but also boundless opportunities. The ability to inspire and unleash creative energy is unrivaled in history, and it all begins with a new paradigm for a new age.
I am a 21st century teacher.
I don't have all the answers or all the knowledge.
But I can prepare my students to find the answers and to formulate the solutions.
Because I have the key.
I have a question.
Many individuals are successful in school and college, successful at work, at home, and in social situations. These individuals are not just very smart or highly intelligent, they are simply self-regulated learners. Welcome to my video. My name is Bayan Kutub. I'll talk today about self-regulated learning. Throughout this video, you will learn what is self-regulated learning, why self-regulated learning is crucial to success in learning, and what are self-regulated learning strategies that you can integrate to learning practice. Self-regulation is the ability to control thoughts and actions to achieve personal goals and respond to environmental demands. Self-regulated learners are metacognitive, motivated, and strategic, and I'll explain each one now. Self-regulated learners need to be metacognitive. Metacognitive means to be aware of your strengths and weaknesses as a learner, to be aware of the demands that tasks make on you, and to be aware of the strategies that you can use to solve your problems and cope with the task that is hard for you. Self-regulated learners are motivated. They are genuinely interested in learning, believe that ability is incremental and can be increased through effort, focus on personal progress, willing to try challenging tasks, persist when faced with difficult problems, and view errors as opportunities to learn. And finally, they are strategic, which means that they have a number of strategies to use and recognize when and where to apply these particular strategies. So, why self-regulated learning is important? A major function of education is the development of lifelong learning skills. After graduation from high school or college, young adults must learn many important skills. For example, in business, people are often expected to learn a new position, such as selling a product. By observing other experts and by practicing on their own, those who develop high level of skill position themselves for bonuses, early promotion, or more attractive jobs. There are 3 stages for when self-regulation aids the learning process. First, before the learning task, the learner should analyze the task, set goals, and develop a plan of approach. Second, while performing the task, the learner needs to use specific learning strategies and observe how well those strategies work. Third, after completion of the learning task, which involves self-evaluation and causal attribution. Causal attribution means beliefs about what caused the outcomes. Now we will move to a set of individual strategies that are usually used by successful students. They fall into 3 categories: personal, behavioral, and environmental. Personal strategies usually involve how a student organizes and interprets information. Personal strategies include 1. Organizing and transforming information through outlining, summarizing, rearranging of materials, highlighting, flashcards, index cards, draw pictures, diagrams, charts, webs, and mappings. 2. Goal settings and planning settings, sequencing, timing, completing time management, and pacing. 3. Keeping records and monitoring through, for example, note-taking, list of error-made, records of marks, portfolios, keeping all drafts of assignments, etc. 4. Rehearsing and memorizing, written or verbal, mnemonic devices, teaching someone else the material, making sample questions, using mental imagery, and using repetition or other ways. Behavioral strategies involve actions that the student takes. It includes self-evaluating or checking progress through task analysis. For example, a student may ask himself, what does the teacher want me to do? What do I want out of this? Self-instruction. Environmental strategies involve seeking assistance and structuring of the physical study environment. 1. Seeking information from library resources, internet resources, reviewing cards, rereading records, tests, or textbooks. 2. Environmental structuring. Selecting or arranging the physical setting that you are studying in, isolating or minimizing distractions around you, breaking up study periods and spreading them over time. 3. Seeking social assistance from peers, from teachers, or other adults. This was a brief overview about self-regulated learning. Many resources are available online for more strategies for you to learn.
Created using Powtoon.
Deep in the Himalayas, on the western edge of the Tibetan plateau, lies Ladakh, one of the highest and driest inhabited regions on Earth. Scorched by the sun in summer, frozen solid for 8 months of winter, this is a place that might seem incapable of sustaining human life. Yet over the centuries, fields have been carved out of the rocks and sand of the desert, enabling the people not only to survive, but to prosper. But the face of Ladakh is changing.
Agriculture is dying. Most people are coming out of agriculture.
The modernization of Ladakh calls into question a number of widely held assumptions about industrial society. In fact, it challenges us to reassess the whole notion of progress. Helena Norberg-Hodge has spent much of the last 18 years in Ladakh.
I know it might sound far-fetched, but I'm convinced that looking at Ladakh can actually help us to better understand what's going on in the West. When I first went to Ladakh, there was no pollution, no crime, and people